So we're going to work on developing a multivariable regression model. This will all be linear. We've already in previous examples looked at the relationship between percentage of free and reduced meals served in a school system and the amount of federal child nutrition per pupil expenditures that are available to that school system. Now we want to include in the model some region effects. So we have three regions in the state: central, western, and eastern. And so we want to include those variables. So not only will this be a multivariable regression model that's developed, we'll also need to use dummy variables to account for these regions because they're qualitative categorical variables. So we're going to insert some new columns here. And the way this will work for dummy variables, we don't need all three options to be represented in the model. We actually shouldn't represent all three in the model, because if we have just one less than the total number of options, so we have three options: central, western, and eastern, we only need to have two in the model, because if our dummy variables, they're binary, 0 or 1, and if it's not western and not eastern, it must mean it would be central. So we will leave central out in terms of a dummy variable and just do western and eastern, and if it's neither of those, it means it must be central. So if we'll set up some if-then statements. So if this cell equals western, we want it to show up as a 1 in this cell. We can drag that down or double click, and we should see 1 showing up in every location where it's western. Then we do the same thing. So for this cell B2, any instance where eastern appears should show up as a 1. And so again, we'll see that in these instances where these school systems are in the central region, we will see zeros for both western and eastern, meaning it is in the central region. So we only need two columns, two dummy variables, to represent the three possible options that are available. Another requirement in Excel for doing regression with multiple variables is that all of the variables have to be in contiguous columns. And so we've satisfied that in this, so we will select columns C, D, and E to run our multivariable regression for this analysis. So to do this, we're going to select data analysis, regression. For our input Y range, we're trying to predict the child nutrition per pupil expenditures from the federal government. For our X values, so our regressors, what we're using to predict, we're going to use which region it's in, western, eastern, and then of course we left out our central region dummy variable, and then the percentage of free and reduced meals. We did select the label, so we need to check that, and this will be placed in a new worksheet. We'll name this one multiple regression. An earlier example with single regression is also provided here. So let's just focus on our actual model. So we have an intercept of negative 117.33. We see that if a school in the western region would expect to receive 0.696 or $6.96 less than a school in the central region, and in the eastern region these schools would expect to receive $20.08 more than in the central region. And then our relationship with free and reduced meals is $936.61. The federal government per pupil expenditures will increase per unit change. One thing we can also look at, the p-values are very high for the region variable, so they're not significant. It's possible that these coefficients actually are equal to 0, but it may be important for your model. You might want to consider having these regional effects, but it does depend on whether or not those are important variables in policies or in planning. But in terms of a statistical perspective, these coefficients are not statistically significant and they could be actually equal to 0. In terms of developing this model, what does the actual model look like? We have per pupil federal child nutrition expenditures that is equal to negative 117.33 minus 6.96 multiplied by Western. This will either be a 0 or a 1. So if the school is in the Western region, this would be a 1. If it's not, it would be a 0. Plus 20.08 times Eastern. And again, if the school is in the Eastern region, this would be a 1. If it's not, it would be a 0. And then plus $936.61 multiplied by, really this is a proportion of the free and reduced meals for the school system. And so that's the equation that we are given from our regression analysis. So if we were looking at actually what would this result in? So let's say that we have a school in the central part of the state that has a 50% free and reduced meal percentage. So again, child nutrition. So for this example, we're doing 50% free and reduced and central region. So for Western, we'll have 0. It's not in the Western region. It's not in the Eastern region, so that's a 0. And then 0.5 for our free and reduced meals. And we'll come up with an estimate of $350.98 for this scenario. Let's look at another one. Let's look at that same percent free and reduced for Western. So now the only thing that changes is we have a 1 instead of a 0 for the Western region. We're actually going to see a lower prediction for the Western region. And then let's also do the same thing for the Eastern region. So now we have a 0 for the Western and a 1 for the Eastern. And now we see we have a prediction of $371.06. So this is our looking at the same, holding the free and reduced percentage the same. This is the regional effects for that same 50%. And you could make adjustments to this. So if your school actually had, a school you were investigating actually had 70%, you can change 0.5 to 0.7, and we'll see a prediction now of $558.38. So this is how we can actually apply the equation that we developed or generated from the multiple regression.